So we have this collection of users. That's our data set that we're going to work with. I basically just created all the great names of IT and threw them into a table, and it's just something to search on. Nothing really relevant. I'm not implying that I'm one of the great names in IT. Let me clarify that first. Although I could. Anyway. So the idea is we've got some data, we have a form. Like these elements itself is not a big deal, but it's what do we do when we click that search button? How do we facilitate that search? So the search button is really kind of the trigger. That's where a majority of this lecture is going to focus, is how do we facilitate this search? All right. So what I've done is, just to kind of give you the full scope, under my app config, I've set up a connection string to my database. So I have that in place. I can utilize that. So the first route, I guess I should say, is that I'm going to go ahead and create a utility class that does the querying of our data, loads it into some objects. So similar to what we've done in past lectures. So I'll go ahead and just create a couple folders. We'll do one for models, and then we'll do one for utilities. And inside of here, we'll create a user model. So we'll have first name, last name, put an email address, went ahead and put a password field in there, date, time, and that's the birth date. And then we also have a date, time for last login, a date, time for created on, and I think that's everything. Yep. Okay. So that's my model for my database. So basically for every field, I created a property. Then inside of utilities, I'll make a user's utility. And so this is going to be handling our connection. So what I'm going to do is I'm going to use the interfaces and build that out. So IDB connection. This will be our connection object. IDB command will be our command object. IDB data reader. Data reader will be our reader. And then we'll have some public methods. So most simplistic one will be a user array, and this will be get all users. So we'll just start there. So our connection will be a new SQL connection. We'll need the connection string. We'll pull that from the configuration manager, which I need to include as a reference. So add reference from assemblies, and we'll search for system.configuration. Bring in that library, and it'll give us access to the configuration manager, the connection strings, and this is just called the database. And we'll grab the connection string property from that app config. So taking it from app config, here's my connection string database, and now I'm pulling the connection string value. So I'll pass in that string, and I'll say create command, and then the command text will be select all from the users table, and we'll execute a reader, and then while we have records, I need a list of user. So this will be our user collection, what we're going to return. then we'll have a user U equals new user. The first name will be reader first name. So I'm just going through and doing that mapping like we talked a few weeks ago. So this is just really a refresher for you guys. You guys all pretty comfortable with this up to this point, based on what you've been doing in your projects? All right, good. Any questions about it? No questions means you understand everything perfectly. Alright, and then we'll just add that user to the collection. So looping through the results set, capturing all those users, and then the final step is to return the user collection. We'll convert that to an array. So we now have our utility class to go fetch all of our users out of the database. So coming back to our button click, now we need to actually get all those users and perform our search. So we'll do a user array, all users equals, oh, I'm sorry. So we need a user utility. And we'll call get all users. And then we'll perform our searches. So to perform the search, what would be your kind of knee-jerk or natural decision of how would I do these searches? Just somebody throw a dart at the wall. What was that? Looping, okay. Looping and doing what?
Filling the variables through each loop.
Okay. So we have 4 different search parameters. So what would we want to do with those parameters? Would we want to validate them before we, or check to see what we need to search on? Because obviously if we loop and check each property, if we have a blank field, we don't want to search for a blank, right? So we probably want to validate what our search parameters are. Oh, I hope I didn't just delete that accidentally. Okay. So we have a first name, this is txt first name. So now that we have this collection, we can do things like this. We can say from you in user in all users where there we go. Where u dot first name equals first name. So we'll just start simple. Select U. So it looks kind of like a SQL statement, right? It's a little upside down. First time I looked at it, I'm like, why did they do it backwards? It's so weird. So you can read it a few different ways. You can basically say, from all users, take you one item from the collection. This is your logic conditional, where the username from you equals that first name that we just pulled from the text box. If that's true, return that user. That user then going into this variable matches. Matches becomes a collection of users. So if you want to extend that query, you can say and u.lastname equals last name. So let's just go with that for now. Data grid view 1 dot data source equals matches. So we'll bind the results to the grid. Consistent. Oh. Forgot to make this public. Kevin Gantos, hit search. Oh, oops. Forgot to open my connection. Email address. Let's try it again. Okay, so I'm getting my result back. Why is it my grid refreshing? Okay. guess you need to have an enumerable collection. Okay, so we get back our results. So let's try a different scenario. Okay. So we're building out these sequels type statements to facilitate the searching. So this is a very simplistic scenario. We can do more complex scenarios by doing things like joins and groupings. We can do order bys. We can even do subselects. So we can take an object, and then we can grab certain properties out of that object and create a new, what they call anonymous object type, as our return value. So for example, let's say we didn't want all those details, but we just wanted first name, last name, and email. So we can say new u.firstname, comma u.lastname, comma u.email. So what C# will do is, as it iterates over that collection, running your logic statement and doing that work, it will actually create what's called an anonymous class and return that anonymous class with only 3 fields: first name, last name, and email. Now within your code, you can actually access those by saying matches dot, let's grab the first item, and you'll see that there's only 3 properties that are accessible to you within that matches collection. So what is matches, you may be wondering? Matches, if you mouse over it, it says that it is an IEnumerable of tilde A. Any anonymous type is identified with the tilde A, tilde B, so forth and so on kind of notation. So what's happening here is that Visual Studio, when it compiles the C# code, it actually goes, oh, this is an anonymous type, something that doesn't exist. And it infers from these field names what the names of that anonymous class's properties needs to be. So it says you have you're passing in first name, you're passing in last name, you're passing in email. So when the compiler actually goes in and creates a class for you without a name, because it's not relevant to you, it creates that class, and then from that point forward, as long as it's within this method, you can access the properties of that class. So this, we could actually go in and create a class that has a first name, a last name, and an email property. But for this sake, we only needed to bind to our data grid view. So we can create this anonymous type and then pass the results to our data grid view. So if we restart and run, then we just get back those 3 properties. We don't get back the full user object. So that's somewhat of an overly simplistic scenario. But let's say we wanted to do a count. We wanted to do some groupings and some count scenarios. So instead of doing our search, let's say we group u by u.birthdate.year into G users. So what this is saying is I want to group you, the users, by the birth date year. So going into each user, going to each user's birth date, and then grabbing that year, it's going to group by that type, by that value. And then it's going to take that grouping and put it into a new variable called G users. G users represents a key value pair. The key is whatever you grouped by. So in this case, the key in this collection will be years. So we have different years. We have like 1973, 1955, 1964, 1983. Those years will become the keys in that grouping. The value will be the collection of users that match that key. So whoever has a birth date in 1955 will show up as part of the value side of that key value pair. I know for a fact Steve Jobs and Bill Gates were both born in 1955. So that particular group unit, 1955, will have both Steve Jobs and Bill Gates in that collection. So you're able to do some aggregate work, aggregating work, on your data sets in your C# code. Now, traditionally, you could go through and you could write a whole bunch of for loops, and you'd have to iterate over that data and set up a dictionary and start building your dictionary, adding your key value pairs. Perfectly valid way of doing it. But would you rather spend 15 lines of code building that key value pair collection? Or would you rather do it in 3 lines of code, allowing the people at Microsoft to do the grunt work for you? If you're in a case where you're trying to build a very large application and you don't have tons and tons of time to spend building your own aggregator, these are pretty nice little tools. So you notice here that U is no longer a valid variable because now everything is in the scope of G users. Now with these anonymous types, we can also create custom properties within here. So we could say that the year property equals gusers.key, comma, users equals gusers. So we'll just create a variable called a group. And by the way, if you're wondering, have I taught about var yet in this class? Okay, I didn't think so. So var, anybody coded in JavaScript before? 1, 2, okay, we got it. Okay. So you declare all your variables using var, right? Okay. Nice thing about JavaScript is that it is not a strongly typed language. Basically what that means is that you can declare a variable, you can stick a string in it, one line of code, the next line of code you can put an integer in it. It doesn't care, and it completely deals with it 99% of the time perfectly. C#, you have to say, this is an int, this is a string, this is a date time. You have to be explicit. That's considered a strongly typed language. Utilizing var in C#, they said, we need to have these scenarios where we don't exactly know what type it is until that variable is initialized. Prime candidate is an anonymous type. You literally don't know what the type is until you compile. So, how would you create a variable of that type when you don't know what it is yet? So what var does is it says, I'm going to be this blank empty object, a lot like what you experience in JavaScript. It's just an open variable. But the moment it's set to something, and it has to be set upon declaration. So if you say var matches, you have to say equals something. If you don't do that, the compiler will say you can't declare a variable type var without initializing it. So by doing the initialization, you're setting its type implicitly. So the compiler, when it goes through and compiles this code, it says, oh, there's a var, matches as a var, so I need to look on the right side, and it'll go through and it'll say, oh, okay, it's an anonymous type, so it creates a type here, and then it goes back and it replaces var with whatever that type name is. Simplistic example. So var a group equals Kevin. So the compiler will get to this point, it'll say, oh, this is a string, so that var needs to be changed to a string. If I reference a group later on in my code, and it might be hard to read, but basically the IntelliSense says local variable string, a group. It implies it from what it's initialized to. So I can say a group equals Bob, and it's perfectly fine with that. if I try to say a group equals 1, it'll actually give me a compiler error yelling at me and saying, you can't stick an integer, 1, inside of a string variable. Because based on how it was initialized when it was declared, a group is a string. Now, if I go up and change it from Kevin to 20, everything works. Because I reinitialized it as an integer, so now the compiler says a group is for ints. It's very handy to use that, especially when you're trying to build out conceptual code. You're trying to take a concept and kind of proof of concept things. You're trying to get things working quickly, and you're not, a friend of mine always says it's like stapling Jello to a wall. You're totally not sure what you're trying to build at this point. You're trying to kind of flesh out the details. So that var becomes very handy. It's still strongly typed. It's not like a JavaScript variable. But if you get 5 lines down and go, oh, I really need this to be X type, you just change the declaration and everything adjusts. When you're dealing with LINQ statements, my recommendation is always to return it to a var. Now, can you return it to a strongly typed variable? Absolutely. If you know what your return type is, I recommend it. But if you don't, you're safe to use those var types. So in this case, a group, what I'm going to do is grab matches.first. Now, before I go on, I want to mention, so matches is a collection. It's a collection of results. You'll notice there's all of these methods that exist off of this collection. I keep using this first method. Well, what these methods are they are actually the function equivalent of LINQ. They're actually called extension methods. And what they're doing is they're extending the functionality of a collection to give you this additional capability. So first is an extension method that takes a collection and then returns the first element of the sequence. So basically, if we had a collection of 10 items and matches, first just takes the first one off the top. Yeah.
So it can be a double and an integer if it's initialized as a double. Because I was just thinking about that and I tried it. Does that work for floats too?
Yeah, so yeah, if you have floating point numbers, you can store integers in them.
Okay. But if it's initialized as an integer, you can't make it a double?
Correct. So yeah, you can't store a decimal number in an integer, but you can store an integer in a decimal variable type. So if I say first, it'll grab the first the first item off of the matches collection. So now a group has a collection of users and a year. Those two variables, because I created them up here in my anonymous type. So let's say, for example, I didn't care about who these users are, but I wanted their count. I can just change this to say count, gusers, count. So then I'm going to take those matches, F5 again, search, and now I have an aggregate collection of years and counts. Now I could say order by maybe it's here. Okay, I guess that's not going to do it. That's okay, so I can show it this way. So matches equals, what I want to do is I want to sort those years. Matches.order by. And then this extension method on order by allows you to tell it what property you want to sort on. So I'm going to introduce another concept too. It's called the lambda expression. So if you look in here, you'll see that this order by takes a function, and this function is a delegate type. So if you remember back from way back early in the term, we have delegate type. So this delegate type function, if you pull up the definition of it, it takes in as a parameter an anonymous type A and returns what it refers to as T key. And that's the key selector. Okay, what the heck does all that mean, right? So if we were to actually create a function, we would create a function that looks something like public T key sort matches T item T key T item element return T item dot element dot that's not going to work very well. Banana. Year. Good luck with that. Ha, that worked. Okay, let's just assume that worked because it's for demonstration purposes. Okay, so I'm throwing a lot at you today. So if you're going, what? Where did he just come up with this? You're supposed. All right. So what I did is I attempted to implement that function. So that function is expecting to pass in an anonymous type, and it's expecting you to return a value of T key. All right, so anybody here know what a generic is? If I use the term generic, you should have dealt with these a little bit in Java, maybe not. No? Okay. So the generic allows you, in C++ it's referred to as templating, and that actually makes a little bit more sense in using the term generic. The idea is when you're creating a variable that consumes another type, you want to leave it open-ended. You want to leave it so that at compile time, that type is declared. Okay? So let that kind of roll around in your head for a minute. What's a good example of that? Probably the most obvious example that you don't even realize you're using, assuming that you're using these, is you ever use this? You ever used a list? You gotta do that weird angle bracket deal and put in the class in the middle? Okay. This, in the angle brackets, is referred to as a generic. List is referred to as a generic collection. If you actually were to ever look at the docs of a list, click F1, you'll see that it talks about it represents a strongly typed list of objects. It lives underneath system.collections.generic, class is list, and it takes T. So T is that placeholder for the type. So within your code, you can say list of users, or you can say list of string. And then what happens is strings says add, and it wants a string. You say users.add, and it wants a user. It decides what type it will consume based on the generic declaration, what you put in those angle brackets. So whenever you see something that says, hey, I have angle brackets, that means that it's expecting you to define or give that type. Now what good is that? What does that do for you? Well, when you create this generic within your code, if you were to write your own generic, and I recommend it, I actually am thinking now I may make that part of your homework. It allows you to say here, I don't know what this is yet. I want it to be T. Here, I'll show you. So let's say we're going to create our own collection. And I want my collection to take any type. I'll just do an overly simplified version of this. So I'm going to say T. So private list of T. My inner collection. Constructor. And we'll say my inner collection equals a new list of T. Okay? So T is the type, right? I can now say public void add T item. I'm treating T as if it was a class. I can say my inner collection dot add item. You notice that list T says that it takes a type T. So I can pass that item in. I can say public T array items. I could say return my inner collection to array. Public void remove T item. Alright, so I've now just created a generic collection of my own. With this collection, I can now go back into my other code. And where I have list user, I can replace this with my collection. You see how it has those angle brackets? User. And now what happens to my add method is that it expects a user. I didn't code it to expect a user. So what happens is that T, basically if you think of it as a placeholder. At compile time, it again, like the var, gets swapped out for whatever that type is that I put here. So these collections, assuming this is my collection as well, basically become strongly typed or unique instances of collections that only accept that type of variable. And the goal is that you create these types so that you can only store one type inside of it. You can only store a user in this list. Now there's another variable type inside of the framework, you may have stumbled across it, called ArrayList. Well, the ArrayList is not strongly typed like this. It says, I take an object, I return an object. So it's your responsibility to keep track of what type of objects you put into that ArrayList. If you put users in there, it'll take a user, because everything inherits from object. But then you say, give me back the user from that array list, and it says, okay, here's an object. It doesn't know what it is. It can't validate that what went in was an object, and it can't confirm to you or verify to you that what it's giving back is an object. You have to cast it and cross your fingers. and hope that it's an object, that it's a user. By making it strongly typed, you ensure that it is. So what does this have to do with the function? I can create functions with delegate placeholders. So what the order by was expecting is it's expecting oh, let me uncomment that. It's expecting a function. Well, this function definition is a generic as well. So if we were to pull up the function of func, or actually let's do this, func f1. That's not the one I want. That's the one I want. So this delegate returns a t result. So think of this as a function definition. This is the blueprint of what a function needs to look like. It takes in, or I'm sorry, it returns a t result, which it defines here as part of the generic, and then the input parameter is t, and that's the argument. So if you create a delegate variable utilizing this template, you can say, okay, I'm looking, instead of creating your own custom delegate every time, you can say, I'm going to create using the function generic, I can say, I need a function that returns a string and takes in a user, and I can call that function get first name. Or in this case, the order by is saying, I'm going to take in that anonymous type, because I am a collection of anonymous types, and I want you to return a result. In this case, that result is what we want to sort on. Now, does the order by function know what we want to sort on? Do they want to create 30 different overloads because you might want to sort on a string 1 minute and a date time the next minute, or an int the third minute? No, they said, pass to us a function that returns whatever you want to sort on, and then we'll sort. Sort routines are easy once you know what to sort on. The hard part is figuring out what to sort on. So if this function returns what to sort on, then that order by says, okay, I'm going to take this collection, I'm going to use this function passing in every object, item, from my collection, and then this function is going to return back to me what I need to sort. And then I'll sort those objects based on whatever it returns. So it's going to return the year. So, pretty slick, right? It allows you to kind of have this universal sort mechanism. So what's the downfall? Well, the downfall is that we have to write functions that look something like this in order to pass them into the sort routine, the order by, to get it to actually do the sort. And even after I wrote it like this, it still doesn't really work. So what this is trying to say is, okay, T key in this case is the result. The method is called sort matches, and it's trying to say I take in a T item and a T key. Let me maybe switch these around and it might work a little better. The problem I have is that I don't know what year is. So what I'm using is another new type called dynamic. Dynamic basically says at runtime, figure out if that variable has a year property. If any of them you need to worry about and be very hesitant of using, it is dynamic. So this element may have a year property, it may not have a year property. It treats it as a key value pair. It basically says, does this object have a property named year? If it does, I'm going to return the value. I don't know if it's a string, a date time, an int, I don't know what it is, but if there's a year, I'm going to return it, and I'm going to hope that it all jives. You'll see this used a lot in web service consumptions, processes that call web services and grab things back like JSON. JSON comes from that JavaScript arena. So, and JSON generally is not very good at being consistent and strongly typed. It's very dynamic. That's one of the benefits of using things like JSON. The problem is you may get a collection back and it may have a property, it may not have a property. And it may change and shift as the web tends to do as things evolve. So being able to say, I'm not really sure what this is, but I know it's a string that gets converted to an object. You can say, cast it to a dynamic, cross your fingers and hope that you get what you need. 99% of the time you will, until somebody changes their code and then that breaks your code. So that's kind of the catch-22. So dynamic is very powerful. Dynamic is used throughout the .NET framework, especially when you get into a lot more of the web development. It allows you to just magically create properties on objects that may not have properties. But as you can see, magically creating things can be by Jim Bar. So keep that in mind. So I'm trying to kind of fake it by saying, you treat this as a dynamic. I know there should be a year there. If I pass this in, it still doesn't like it because it doesn't know how to take T and convert it to dynamic. So it's not a big fan of that. So lesson there is there a better way? So Microsoft came up with another solution. They said, let's create what are called lambda expressions. So what does a lambda expression mean? Well, a lambda expression is the shorthand for writing delegates. So we try to write a function. Delegates are function variables. You can create what are called anonymous delegates, and I'll show that in a moment. But what they came up with was something that's super shorthand and super easy to write once you understand it. So this is what the lambda expression looks like. Anybody want to take a guess at what that means? First of all, does anybody know what that means?
I'm just trying to figure out where you get the M from.
Ah! Good. All right, I'm going to deconstruct it slowly, and when you see it, yell out Yahtzee or something. So what if I do this? Nothing?
I mean, to me it sounds like it's like for every member, for the members here. I'm just.
Yes.
I mean, I'm just.
Yes, that's exactly what it means. So M is the parameter of the function. So if you remember, that function wants one parameter in, that's T. And then it returns a result. So what this is saying, before I put the parentheses and the user around it, it's saying M is that one parameter. So when you call this function, the function is M is the parameter. The arrow then says whatever comes after this is the body of the function. Whatever is, what's the word I want to use, evaluated, return that. So in this case, it says take N, the user, so maybe it makes more sense if I make it a U. Actually, I'm not even using user, so I can say user, user.year. So take the user from matches and sort on the year. So there's a whole lot of magic that's happening at the compiler level to make that work. So basically, users turns into a parameter of a function. The stuff to the right of that arrow turns into the body of the function. So the equivalent, still using loose lambda syntax, would be user, curly bracket, return, oops, sorry about that. So that looks a little bit more like a function, right? Pass in a parameter, user. Not sure why it's yelling at that. Take that user.year and return it. Year has no. Oh, because that's not user. That's our anonymous type. I didn't think it was going to like that. And that's why you don't give them types. So user really isn't a user, it's this, whatever this anonymous type is. But we can think of it as a user. So that's why I use the M for match. So if you want to do full function bodies, you can put those curly brackets after the arrow and you can treat it as a full function. But normally you just do this. It's simple, it's clean, a little overly simplistic sometimes. If you ever dealt with regular expressions, it kind of ranks right up there with regular expressions. Regular expressions are a whole animal. So something like an order by, that makes pretty good sense, right? Not too off the wall. Sort by this property. We can chain this with another call. We can say matches.thenBy. We can pass another one of these lambda expressions, m.count. So sort by this, then by that. If we were doing user, sort by first name, then by last name, or last name, then first name.
Descending.
There is methods for sort by descending, then by descending, however you want to do that. We can also take this LINQ statement and rewrite it like this. var matches equals all users. Group by, and this is where the LINQ statements get crazy. U dot birth date dot year dot, oops, sorry, let me do it this way so it's a little easier to read. Select G users, new year equals G users dot key, comma count equals G users dot count. Personally, this is my preferred way of doing it, the latter. I don't know why. I just feel like I have more control over what's happening in the order that it's happening in, because they're separate function calls. When you do the original LINQ, it works, but if you have either any sort of like complex where statements or strange groupings, or you're dealing with a lot of complex type that you're trying to flatten, which means if you have a lot of properties that have child properties, you're trying to bring them into one flat, where it's just a whole flat level of properties, that gets a little weird doing it up here. Preference, I guess, is the best thing I can say. But these are the equivalents. Some people will argue, but from what I've read, basically this gets turned into this and then it gets run. So I think it happens at compile time, so you're not losing performance. It's just the compiler has to do a few extra seconds of work in order to convert that string into a series of function calls. Yes?
Like statements, regular expressions, doable?
Like statements? So a little bit, yes. So let's say you wanted to do a like statement. So let's get the groupings out of here. And that's the other reason why I like doing it this way, is you can just comment out sections. You don't have to go back and whack the entire statement. So you can say where you, that user, dot last name contains, or actually probably better yet would be starts with, let's just do txt last name dot text. So that would be your like statement, or similar to it, or you could do contains if you're looking for it in the middle.
Okay.
Regular expressions, the same idea. You would declare the expression, you create it before you get into this point, and then in your where, you would have it evaluate that against the regular expression, returning a Boolean of true or false. Oh, and I removed my grouping, so that's not valid anymore either. So we'll say select. Actually, we don't even need a select there if I want back all my users. So if we run this, semicolon, without that other character. So let's say we do G, search. There's your like statement. So that would give you back what you're looking for.
Case sensitive.
You're just throwing all kinds of balls. That's good. I like it. I'm good with that. Are we doing case sensitive like statements, or are we just doing case sensitive or case insensitive?
Ignore case sensitive.
All right. So equals is the function you want to use, and this isn't just for LINQ. This is valid for anywhere in the framework. When it comes to strings, this is a little gem most people don't know about. There's a second parameter you can pass to the equals function on a string, and it's the string comparer. And you have three modes of ignore case: current, culture, invariant, or ordinal. It has partially to do with there is a whole entire culture engine, if I can just use that without giving the real detail. And basically it allows you to cast and convert strings, or more importantly when you're formatting things such as money and dates, so that they're culturally specific. Because money, if you're not aware, is notated differently in Britain than it is in the United States. Numbers are notated differently in Europe than they are in the United States. So that culture feature has to do with that. Ordinal case, or ordinal comparisons, basically is a character for character, value for value. So it takes it and converts it to a numeric entity and then does a literal comparison. It is the fastest and most efficient way to do it. So often I'll do ordinal, ignore case. That does a case-insensitive comparison.
Now combine the like with the ignore case would be something along the lines of contains equals? Or no, it would not be that.
So you would want, I don't know if starts with will take that. No, it does. It would be that. That's exactly what it would be. So that will do a starts with or like ignoring case. I do a lot of data crunching in my job, so I spend a lot of time using these statements. When they first came out back in 2010, they were like the problem, they were the solution to a problem that I'd had for a long time. I would always invest time writing loops and making groups and making new sub-collections and doing all this work. Now, if you really want to get down to performance, if you're processing millions of transactions a second, you'll always want to fall back to using a for loop against an array. It is the most efficient you can get pretty much in any language. Running a for loop against an array. If you're just dealing with small collections, and you know you are, this is a time saver for you in programming. You can bang out 3 lines and be on your way versus putting together 6 variables, a counter, a loop reference, and then trying to build a loop body, making sure that you take care of everything and don't drop something along the way. So weigh your options.
So there's more overhead with this then?
What was that?
There's more overhead with this then?
There is. It's not significant, but it does exist. As you get into larger collections, it's noticeable.
Okay.
If you're dealing with collections of probably less than 500 and you're running it in memory, you're not going to notice it. If you're dealing with thousands, hundreds of thousands, millions of records, you'll notice it. One last thing. I may save it for next week. Because the next thing we're going to talk about is deployment next week, and that doesn't really take that long. There's a lot of old stuff in the book, and it's not really relevant anymore, so I just kind of gloss over the details. I'll wait for next week. The last thing I wanted to show you, just so you have a taste of it, is what's referred to as the entity framework. And what that is it's a ORM, or an object relational mapper. So inside of my utility class, I'm doing the bare bones equivalent, rolling my own mapper of saying, hey, I have a database, hey, I have an object, I need to take data from the database and put it in this object. That process is referred to as ORM. There's plenty of different libraries out there. Microsoft's is referred to as Entity Framework. There's also Hibernate, and I'm sure there's more, but the rest of them escape me. So, utilizing that basically says, hey, I have a database, I have a class. Do some work in the black box and map this table to this model, this object, and then give me back a collection. Doing the exact same thing we're doing here, but it's much more flexible and there's a lot more functionality to it. Plus, it supports LINQ. So you get what's called a DB context or a DB set. You write LINQ statements against it, and unlike doing it in memory, where it basically, so let's say you had 1 million records, okay? So this is where LINQ actually can be a performance gain. You have 1 million records, you want to use LINQ to SQL, is what it's called, or LINQ to EF. And what you can do is you write these LINQ statements, either notation. It will actually generate the SQL statement to run on the server based on the LINQ code that you write. So if you have a table with 1 million records and you want to get everybody that was born in 1955, you write DB set users where year equals 1955. LINQ to EF will convert that into select all from users where birth date year is 1955. And it'll run that query, grab that result set of maybe 5 or 10 or 50 records, and then give you back objects for those 10 records from the database. Versus this method, which, I mean, we could optimize this, but it would grab all 1 million records, and then you'd have to loop through them all, finding the ones that are 1955. So it's actually a nice little piece of functionality. Again, there's this debate. I personally have an opinion on it, but there's this debate of should the programmers really know how to deal with the database. If you're a programmer, you're a programmer. You deal in the space of programming. You don't deal in the space of database. I think there is some validity to that. You know, that's why we have database administrators. That's their forte. That's their thing. They're all about tuning and building and optimizing and doing all that work. I think at the same time, just as with any job in IT, you need to have a little bit of understanding of everything. So if you can write a basic SQL statement, there's no reason as a developer you shouldn't know how to write select, insert, update, and delete, doing the 4 basics. So if you can write efficient code, hitting a database and doing that work, why not do it? So that's my personal opinion on that. But for those who don't know SQL, utilizing the entity framework and the LINQ to EF gives you that ability to write more efficient SQL. Granted, it's auto-generated, so it's probably still not as efficient as if you were writing it yourself, but it gives you more performance. And actually, I'll show you a sample of how it generates very inefficient SQL sometimes, if you don't do it the right way. Any other questions? Yeah.
On the other data utility that you did, where you were defining the artist, or not the artist, but the user
Yeah.
from the database,
Yep.
you had like a bunch of other code
Oh, yes. So I probably did something like reader first name is DB null. Did it look something like that?
Yeah.
Okay. So what this is, I need to look up what this is called. I always use them and I can never remember what they're called. Not a colon. What? Ternary, yes. Did I spell it wrong? Operation. Yes. So it's a ternary operator. Thank you. So basically what it means is it's like the super shorthand for an if statement. So it says evaluate this first half before the question mark. So here's the question. Is this true? So reader first name, take this value, is this DB null? This is the question. If it is DB null, true, return the empty string. Passing the empty string back to first name and making the first name equal to an empty string. Else is the colon. Convert that to a string and pass it. So that's how you read that. I mean, I could put a whole if statement in there, but that's a lot more compact than putting an if statement and doing it property by property. There's another one that's a null check. This one I haven't been able to find a good use for it most of the time. So let's say we have string name, and this is just arbitrary. String new name equals, we can say name double question mark. Not defined. So what this is doing is it's taking the value of name and it's saying, is name null? If it's not null, return it as the value that would go into new name. In this case, Kevin. If it is null, return the string on the right side of the double question mark. So that's kind of a shorthand of if null, return to the right of the question marks. If not, return the value that's being checked. So this is checking to see if name is null. So if I said this is null, it would always return not defined as its string value. So that's just another one. Like I said, I haven't been able to find good uses for that one because I'm usually trying to get at properties or other, like I need to do strongly type conversions or other things. So, turn around. Thank you. Other questions?
How quick, like, if I were to constantly need to reference a database, how, like, if I'm constantly going through my program,
Mm-hmm.
is this something I should be concerned with as far as, like, networking later on?
If you're constantly...
Well, I mean, I don't know, you said that, like, you were mentioning about, how expensive
Right.
um,
So the performance that you're going to deal, well, so you have a lot of factors. If you're doing, so in our case, what we're doing is we're doing one hit to the database with our LINQ statements because we're taking that one hit, we're getting a collection back, and then we're loading it into memory. We're creating objects from that result set.
yeah.
So that's one hit to your database. Is that what you're worrying about or thinking about as performance hits to the database?
Yeah.
In our case, we're hitting the database one time, we're making one call to the database, and then all of the other work we're doing in LINQ is happening in memory. the moment we do this, where we take the values from that data reader and put them into an object, we're essentially copying the data from the database and putting it into memory on the local machine in an object. And then all of the LINQ statements of the wheres and the selects and all of that is happening against the objects in memory. We're not dealing with the database directly.
Okay. So it's more or less you're just taking the database and it's like translating it into whatever you're.
Right.
So if anything, it's speeding it up rather than
Yes.
having to create a bunch of different string statements or whatever.
Right, exactly.
And filtering out for
Right.
how long, whatever.
Right.
It's be.
Right.
It depends on how big you're returning now. If you're returning a lot of data, you want to do a lot of work on the database and bring back a small amount and do whatever work you can there. Whereas if you're only pulling about a small amount of data, pull everything and do it in memory. So
Right.
Depends on how much information you're pulling. That's it.
So if you're pulling 500 records, it's probably about 400K worth of data. I mean, it's probably even less than that. There's compression and other factors. So you're not pulling a ton of data across the wire to make one call and pull 500 records, let's say.
Yeah, I don't even think I'll be even using 500 at all.
Right. So that's pretty low overhead, but you're going to get a lot more flexibility of your data by pulling all of it and then doing it in memory. You can deal with the data in different ways. You can do different calculations and groupings and aggregates and things like that based off one hit. If you've got 1 million records, well, that's a lot of data you're pulling. And then that's a lot of data that you're leaving up to your machine to chew through, whether it's your actual machine or a server or whatever. It's having to chew through that data.
So I guess it boils down to either preparation of planning with your database.
Right.
And just making sure you're using, the right key values you need.
Right. You got indexes on the right fields. You're searching on those indexed fields so that way you've got optimized queries. Something to keep in mind, and this, I don't know why this just kind of came back to me recently. Whenever you think about databases and having indexes on fields, think of it as if you were writing a program where you were fetching all the data from the database and then you were creating dictionaries. Where dictionaries are key value pairs, where every record is the value and then whatever your index is your key. So you've got really fast lookups on dictionaries, but then you're storing all that additional data in the rest of the object. So, when you have 5 indexes on a table, and you're searching on first name, last name, birth date, let's say, having those indexed in the database, let the database manage all that, and then utilize those indexes for performance. Do the searching at the database level when you're dealing with millions of records. When you're dealing with millions of records, and you don't have indexes on your database, there's some argument you could probably make, but I would almost guess that you're probably going to end up getting better performance pulling 1 million records and then doing the search locally, depending on, there's obviously performance factors of how fast is your database and things like that, if you're not hitting any indexes. So it's all relative.
Okay.
Is what it really kind of boils down to, unfortunately. There's a lot of scenarios. You can look up docs around scenarios on what's better performing. It is. It's all relative. You'll find, if you look on Stack Overflow and you ask people about performance and what's better to do this versus that, they will ultimately boil down to, it all depends, you need to do tests. Go ahead.
Going back to your LINQ statements, let's say you got your 4 or 5 different fields: first name, last name, email address, and birth date.
Right.
Now, eventually, you want to work that into your LINQ statement. Is there a shorthand way of checking to see, hey, if this field actually has something into it, added into the select statement, or actually with a where clause?
Mm-hmm.
If it's not, ignore it. Shorthand.
Honestly, not really. That's actually one of my arguments for doing the functions, is because you can chain them.
Right.
So what I would do, so we've got these fields. Collection. Those aren't relevant. I'll leave that there. So you could say all users. Well, actually, we could do it a few different ways. I'm going to get rid of your like, if that's okay. So you can put two logical statements in here. You could say string dot is null or white space.
Right.
So you can say if not null or white space, last name, and u dot last name equals last name. So that would be your check. Do I have a last name coming from my form, and does my last name field match that last name from the text box search? Is that what you're asking about?
Yes. So then when you go to add in the other fields, continue going or an additional where.
Right. So you can either do an additional where, which will make it clearer, but then you're basically working on sets like this. You're like, here's the size of the original set of users.
Trim it.
Trim it, trim it, trim it. Or the more efficient, you're doing all the work in one swoop, I guess I should say, because you can say and not string dot equals or is null or white space first name and u dot first name equals first name. Actually, something you could do. Length is greater than 0. Txt dot first name or null. So you could go this route.
Right.
And then if you did that, you could do that. I think I gotta wrap it like this. So you could do it that way.
So if it comes back to being null, it'll just ignore that and u dot first name equals sections.
Right. Well, what'll happen is say it's kind of, think of it like a SQL statement. So it's saying user.firstname equals, if this is a value, return that. If it's null, that we evaluated above, then it equals itself. It's always true.
Oh, okay, yeah, gotcha.
So up here I said, is the length of the first name text box text greater than 0?
Right.
Is there a value in there is basically what I'm trying to determine. If there is, return that back and store it in the first name variable.
Else it's going to be null.
Else set that to null. Doing that for each one, the date time is the only one that'll be a little trickier, but there's these things called nullables.
Right.
And you can set that equal to null as well. Then utilizing this notation,
Either it's going to be a value or it's going to
be
equal
itself, exactly. And if it equals itself, then obviously it's true, and you go on your merry way. So,
That's what I was looking for there.
yeah. So you gotta do a little bit more work up here, but if you do the work up here, then you can do that a lot shorter down below. So, there you go. So,
Both are essentially equivalent.